So let's continue our discussion on analyzing loop complexities. You might remember that these were few identities that I talked about. Like if you sum over 1 to n, then you will be getting n into n plus 1 by 2. So we might use this. And similarly, like I think in this lecture we will be using this identity quite often, which is basically 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 till 1 by n is as good as saying log n. Okay, we might be using this. And now in the last video we have seen that if you are incrementing by a, then it is n by a. If you are multiplying by some constant, then it is log base that constant, right? It is 2, then it is log base 2. And if you are squaring up, then it is log n, right? Okay. Let's solve these 4 questions. These 4 questions are easy, not that tough. Like you can easily solve it, I think. So let's solve this. See this first question, it is running, like first loop is running n times and second loop is also running n times. So that is why the total time complexity is order of n square. You can also say theta because theta is more appropriate, but order of n square is actually more popular. This O symbol is actually more popular. So I will be using this O symbol. Otherwise you can also say theta. There is no problem in theta, right? Okay, let's talk about this. So here you see that I am running first loop n times, that is okay. Second loop I'm like this is a bit not clear what I'm doing here because I'm running one time, then I'm saying j is less than equal to I, and then I'm incrementing by I. So just to remind you that if I'm incrementing by some constant, then it runs n by a times, right? So where n is this number basically, okay? So if I'm incrementing by I, then can you tell me how much it is running? It will be running I because I, this I is coming from here, by I times because this I is coming here, which means it will just run one time. Why? Because you are initially 1, j is initially 1, and in the next iteration only j will become I plus 1, which will be false condition, right? For j equal to 1 only it will run, right? So that is why it will run just one time. So you will say it will run one time only. So this is just constant time. So that is why the total time complexity of this for loop is order of n only, right? What about this for loop? In this for loop, first loop is running n times. Second loop is saying that you are running it till I square, but each time you are incrementing by I. This is interesting. So second loop will be running I square by I times because it is I by a or n by a basically, right? So n means I square here and by I times, which means I times it will be running, which means that for I equal to 1 it will run one time, this will run one time. For I equal to 2 this will run 2 times, right? For I equal to 3 this will run 3 times, and similarly for I equal to n this will run n times. So if you sum this all of this up, then you will be getting n into n plus 1 by 2, which is as good as saying order of n square, right? It is also theta, but let me just see order. What about this? Here this loop is running n times, that is okay, and this loop is saying that we are running it n divided by I times, right? Because this is n and you are running I times. So what you can do, you can just unroll this loop just like this example. You can also unroll this example and you can say that let me do one thing, let me erase this maybe, and then let me write it very clearly. So you can say that for I equal to 1, you are running this. You are running this how many times? You are saying that you are running n by I times, which means you are running n by 1 times. For I equal to 2, you are running this n by 2 times. For I equal to 3, you are running this n by 3 times. And for I equal to n, you are running this n by n times. Which means here you are running n times, here you are running n by 2, n by 3 till 1 time, right? So which means you need to sum this up, n plus n by 2 plus n by 3 plus dot 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 till 1. So if you take n common, then it will be same as n into 1 plus 1 by 2 plus 1 by 3, right? Plus dot dot dot. Here instead of 1 you will be writing 1 by n because you are taking n common. So this series is actually n log n, right? So you will say this series is log n, so you will say that the final answer is n log n. Why? Because the internal this series is log n, so the final answer is order of n log n. That is how we are computing that how much time complexity this loop is taking, right? Let's see this example. So there are two for loops are given. So first for loop will run n times and second for loop will run log n times. Why? Because we are multiplying by 2, so log base 2n times, which means the final time complexity will be n log n, right? Okay, let's see this example. here first for loop is running n times, but second for loop is actually dependent on I. So I think it is better to unroll. So let's just unroll this. So for I equal to 1, and I will be writing for I equal to 1 how much it is running. So for in general for I, it is running I think log I times, right? Log base 2 I times. So for I equal to 1, it will be running log 1 times. For I equal to 2, it will be running log 2 times. For I equal to 3, it will be running log 3 times, and similarly for I equal to n, it will be running log n times. So that's why I need to sum all of this. So if I sum all of this, it will be log 1 plus log 2 plus log 3 till log n, right? Now it will be log of 1, since since the log properties we know that if we are summing this over like this, then you can also multiply 1 into 2 into 3 into 4 till n. So this quantity is nothing but n factorial, so you can say log of n factorial. And as you know that log of n factorial is as good as n log n, right? These are actually theta, so you can say this is the time complexity, this is order of n log n. Why? And you can also say theta, but that is okay. Why it is order of n log n? I mean, this is log n factorial, but we know this is exactly equal to n log n, right? So I have explained you in previous videos also that n factorial is strictly less than n power n, but log n factorial is exactly equal to n log n, right? So we have proved it, we have discussed this, we have done everything about the overall explanation about this these two inequalities, right? Okay, so let's see this. Here this for loop is running n times, no, not n times, log n times, right? Log n times, and this for loop is running n times, so final time complexity is n log n. Very easy. Let's see this. This is running log n times, this is running, so I think I need to unroll it because this is running I times, right? So for I equal to 1, for I equal to 1, it will be running 1 time. Then for I equal to 2, why I equal to 2, because I am multiplying by 2, right? Then it will be running 2 times, because every time it is running 1 time. For I equal to now I is 4, okay, it will be running how much time? 4 times. Then I will be 8, so it will be 2 power 2, it will be 1 2, then I will be 4 into 2, which is 8, which means 2 power 3. For I equal to 3, it will be running 8 times. For I equal to 8, it will be running 8 times. Similarly for I equal to 2 power k, so 2 power k is actually n, I am treating this 2 power k as n, it will be running 2 power k times, right? So if you sum all of this, then so see what is happening here. I am assuming that it is running k iterations. If it is running k iterations, that after k iterations it will be 2 power k, and I am assuming that 2 power k is n, so that it will stop. Okay, so 2 power k is n or 2 power k plus 1 is n, does not matter, 1 or 2 more iterations does not matter, so that is okay. Okay, so I am saying that for I equal to 1, it will be running 1 time, because it is running till I times. So for I equal to 2, it will be running 2. For I equal to 2 power 2, why? Because every time I am multiplying by 2, so it will be running 4 times, 8 times, and then till 2 power k times. So this will be running till this much time. So if you sum all of this, how much you will be getting? This is the summation of GP. So you will say this is 2 power k plus 1 minus 1 upon 2 minus 1, which means this is just 2 power k plus 1 in asymptotic sense, and then this is just 2 into 2 power k, so you can just ignore this 2. So it is 2 power k, and 2 power k is n, right? Why? Because I have assumed that 2 power k is n, then only it is stopping. So you can say this is running order of how much time? Just see this, order of 2 power k times, right? Because the number of total iterations it is running 2 power k, and then this 2 power k is order of n, so it will be running order of n times, right? This is the time complexity of this for loop. Now let's solve this. So first for loop and second for loop both are dependent, so I think it is better to unroll. So let me just copy this and let me erase this, and I will be explaining all in the after the erase. Okay, so what is happening here? For I equal to 1, what I am doing? For I equal to 1, I am saying that I am running how many times? I am running I square times, right? Because this is only j plus plus, so I will be running 1 time. And then similarly for I equal to now 2, it will be running 2 square times. For I equal to 3, I will be running 3, sorry, it will be 4, right? It will be 4. I will be running 4 square times, which is as good as 2 square in whole square, which is 2 power 4, right? So now for I equal to 8, I will be running 8 square times, which is as good as 2 power cube square, which is 2 power 6, right? Now similarly for I equal to 2 power k, see what is happening. Initially I is 1, which means 2 power 0, then 2 power 1, 2 power 2, then 2 power 3, then then it will be 2 power k, right? So for I equal to 2 power k, which is actually n, okay, for I equal to 2 power k, which is actually n, it is running how many times? So for 2 power 3 it is running 6, 2 power 6 times, for 2 power 2 it is running 2 power 4 times, for 2 power 1 it is running 2 power 2 times, so it will be running 2 power 2k times, right? Because just the power is getting multiplied by 2. So now let's sum all of this. So it will be running 1 plus 2 square plus 2 power 4 plus 2 power 6 plus 2 power 8, right, plus dot 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 2 power 2k. So if you see the common ratio here is 2 power 2. So you can say it is like the formula, if you apply the formula, which is a into r power n minus 1 upon r minus 1. So you will say a is just 1 and then r, which is 2 power 2, and n is number of terms. So number of terms is k, right? So it is 2 power 2, it is the, like you can say the first term, it is the second term, it is the third term. So number of terms will be either k or k plus 1, does not matter. So I am just taking it as k. Okay, so it is basically 2 power 2 is r, and then you will say number of terms are k minus 1 upon r, which is 2 power 2 minus 1. So ultimately it will be just 2 power 2k. So you can say 2 power 2k, and 2 power k is n. So what is the value of 2 power 2k? See, if 2 power k is n, then if you square both of this up, so 2 power k is n, then 2 power 2k, which means you square both of sides, then it will be 2 power 2k. 2 power 2k is n square. So this is just n square. So the total time complexity of this loop is order of n square. See, let me quickly revise it. See, I hope you are getting that how I is getting incremented or getting its value. Initially it is 1, then 2, then 2 power 2, then 2 power 3, and then ultimately it will be 2 power k. And then how this inner loop is running. Inner loop is running I square times. So initially it will be running 1 time, 2 power 2 time, then 2 power 4 time, then 2 power 6 time, and then ultimately 2 power 2k time, right? If I sum all of this, then I need to apply the GP formula. This is the GP formula. So A is just 1 and R is the common ratio, which is 2 power 2, and N is total number of terms. So now to find out the number of terms, what you can do, you can say that okay, it is 2 into 2, it is 2 into 3, right? So it is the fourth term. In the fourth term you are having 3, in the fifth term you are having 4, right? So basically in the k plus 1 terms you must be having this k, right, this k. So you can write k plus 1 or k, does not matter actually, because it will be just constant. So you can say okay, this is 2 power 2k plus 2 or something like that, that will be just 2 power 2k into 2. So this 2 is just constant, so 2 power 2k is n square, right? So order of n square is the final time complexity. I hope you got this whole idea. Okay, let's do the next question. So in the next question I am saying I is 2, and which is I am running this till n times. Each time I am squaring this up, which means that it will run log n times, right? Log n times. Why? Because each time I am squaring this up. Okay, now let's see this these two for loops, inner for loops. So this inner for loop and this inner for loop are both interrelated. So let me solve for this for loop. Okay, whatever time complexity I get, I will multiply this with log n, because this is some independent for loop. So I can solve for this. Okay, I can find out the time for this, and it is taking that much time, log n times, right? So let me find out the time for this. So what do you think? What will be the time for this? See, for j equal to 1, how much I am running? I am running till n by j times, till n by 1 times. So each time I am running n by j times, right? For j equal to 2, I am running n by 2 times. Now for j equal to 3, I am running n by 3 times. So for j equal to n, I am running n by n, which is 1 times, right? So if you sum all of this, you will say n, you can take n common, or let me first, just add this up, n by 1 plus n by 2 till 1, right? And then you can take n common. This is 1 plus 1 by 2 plus 1 by 3, and ultimately you will be having it was just 1, so you will be having 1 by n. So it is log n. So this is n, so you will be having n log n, right? And this is n log n. This should get multiplied by log n. So which means n log n into log n is your final answer. This is the time complexity of this for loop. Okay. Now let's solve this. Here they are saying that for I equal to 2, and then they are running till n, and then I just incremented by 1. So they are saying that if x is mod I or something like that, then we are breaking. Otherwise we are just executing something. So in this if and else, like what will happen? It could be worst case, best case, which means it could so happen that if x is some unknown, right? So let's suppose x is 10, then maybe in the first iteration it will get break, right? Or if x is some prime number, then I will never be able to divide this, then it will always execute this, right? So if x is some prime number, maybe 13 or maybe anything, right? Maybe some big prime number, like whatever it is, does not matter. So let's suppose x is some prime number, and this I is never able to divide this x. Suppose this condition is always false. Okay, suppose like you do not need to know the mathematics of prime number or all. You just say that this is always false. There could be the case which is where it is always false. If this is always false, then you can say, then in worst case I will be executing sum plus always, right? Which means order of n in worst case. In worst case. And order of just 1 in best case. Okay, which means that in worst case I will be taking order means less than equal to. In worst case actually you can write theta both at both of the place, but let me just work with the order. In worst case you will be taking less than equal to n. In best case, okay, in best case you will be taking equal to 1. 1 means like a constant, n means like less than equal to cn or less than equal to c1. So anyway, so basically actually you less than equal to, okay, you can write theta, which means if you write theta you can say it is actually not less than equal to, it is equal to, which is true, right? So in worst case you will be taking order of n or theta of n. In best case you will be taking just one time. So if this is conditional, then there will be cases. If there is no condition, then you can directly find out the time complexity. What about the time complexity for this? Now if you observe, then what is happening, then we are doubling each time, right? So it should be log n, it should be log n. But just look at this very carefully. Is this log n or there is something which we are missing? I think we are missing something. And what is that? We are starting from 0, right? If we are starting from 0, we are each time multiplying by 2, it won't happen, like nothing will happen, and then it will remain to be 0, right? Which means 0 is less than n, it's always true. So basically it is an infinite loop, right? So before coming to the conclusion, just see the initialization and every condition carefully. Just by looking at, okay, into 2 does not mean that it is always log n. Okay, sure, thank you.